here's how we'd proceed. Nice result. The question is, how do we justify the steps to get there? So let's go back and look at what we did and justify each of the pieces. We know the difference quotient is defined as this guy here, f of x plus h minus f of x over h. So the first step, and this is a personal preference, I like to look at f of x plus h by itself. Often that takes some work. If you go ahead and do it once, then you can plug it down here into the formula for the difference quotient afterward. So plugging this in, f of x plus h means go to the original, replace each x with a set of parentheses and jam x plus h in place of that x. So if you look here, we had an x right here, negative 2x squared, so we replaced the x after the negative 2 with a set of parentheses and jammed x plus h in it, and then the squared. There was plus 3 and then an x, so we have plus 3, and instead of the x behind it, we replaced the x that was up here with a set of parentheses and x plus h. And then at the very end, no x, so we just had the minus 1 tagged on at the end. After that, we went ahead and did two things. First of all, we took the 3 and let it get distributed into the x plus h. So it multiplied into each one of these, which gave us 3 times an x, 3 times an h, both positive. The other thing is x plus h is squared. Squaring, of course, means multiply something times itself. 5 squared, for example, is 25 because it's 5 times 5. So here, x plus h squared means take an x plus h and multiply it times the exact same thing. When you do this, you're going to have to do some distribution. You're going to have to let the x hit this x. When it does, x times x will give us in the next step x squared. Then come back and let this x hit the h. That'll give us x times h, which we have right here. Run back to the first set of parentheses and grab this little h. Let it get multiplied times the x, so we'll write it as hx. And then the last thing here, we'll have h times h, which is h squared. We need to combine some things inside of these parentheses, and the justifying thought process is xh or hx is the same. If they were numbers, 2 times 3 is 6, or 3 times 2 would also give you 6. So multiplication, the order does not affect us. So what we'll say is this xh is really the same as this. We could have written it as xh. 1xh plus another thing that's really the same as xh gives us two things that are like xh. So all we did here was combine the xh terms that were getting multiplied. Then we take this negative 2 and let it get distributed onto the inside of the parentheses. So that'll give us here negative 2 and the x squared. Negative 2 times this guy will give us negative 4, x and h. And then lastly, negative 2 times the last term will give us negative 2h squared. Everything after the parentheses has remained the same. It's just copying it each time. Once you've gotten to this point, that's the majority of your work right there. The difference quotient can now be written easily. The top left corner of the difference quotient formula is everything that we got right here. This is f of x plus h. So the top left of our fraction, we just copy all this and jammed it into the top left component or part of the fraction. Negative 2x squared minus 4, it just follows all the way up to the negative 1. That's the top left. The one thing that most people make mistakes with in the difference quotient, and it's because of the way it's written, it says subtract the original. The thing is that if your original has multiple components, like ours does, negative 2x squared plus 3, these are multiple pieces. You really should just put a set of brackets or parentheses around the original. Why? Because if you don't, you're only going to subtract one part of it. And you're not supposed to. You're supposed to subtract the entire original. So here we see the negative and then the brackets for the original. Then this negative will get distributed and it has to hit each of the components of the original. That's why we want brackets, in order to make sure this minus sign is actually going to touch all the pieces of the original function. Once it does, you distribute the negative n. Negative, negative will make it a positive. Negative and positive here will make it negative. Negative and negative at the end will make positive at the end. I personally don't like to do this step, the one that brought the negative n. Why? Because when you look back, especially with polynomials, you're going to end up trying to cancel the original components that you started with, hoping that the opposite is somewhere earlier in this difference quotient. So for example, negative 2x squared is here. We should go see if there's another one. And sure enough, the first term is negative 2x squared. So this one we're hoping will cancel. And in fact, after that minus gets distributed, we see we got this to be a plus, while the one up front still stayed as a negative. So that means that this negative 2x squared canceled with this one. And we knew it was coming because we were trying to see if we could get this guy to cancel in the first place. Then we'll move to the next term. The next term here is this positive 3x. So we go back in and say, hey, where is positive 3x? And sure enough, we've got positive 3x here. He'll stay. This guy, because of the minus, makes him negative. So all of a sudden, this positive 3x is going to cancel with this negative 3x, another component from the original. And the last one, of course, minus 1 is what we want to get rid of at the very end. Minus and minus made it positive, so there should have been a negative 1 somewhere prior to our minus sign. And if we go back here, we see, ooh, here's minus 1. It's still hanging. This minus 1 is going to cancel out with the now changed sign of the positive 1 on the end. So at the very end, this guy and this guy will cancel out. What this leaves us with, and I wasn't as careful as I should have been, we'll still have a 3h. That didn't get canceled, just the minus 1 did, so the 3h will appear. The minus 2h squared still appears. And minus 4xh also appears. Everything else canceled from the original. That's what you should look for. Down here, the h's will cancel. Just for the sake of clarification, occasionally people aren't familiar with or comfortable with what's canceling and how. The common denominator is h. So you could say, as an or statement, this could have been written as negative 4xh with a common denominator of h. This next term would have been minus 2h with a denominator of h, and the last term was plus 3h with a denominator of h. Now, careful, the original middle term is actually squared, so it would have started this way. Now it's very clear to see how they canceled. This h would have canceled with that one, leaving us a minus 4x. This h cancels with the power of 2 and drops it down to 1. So we'll still have an h. We'll have minus 2h, which is what we see in the next term. And the last guy here, h and an h cancel, which gives us a 3. So be very, 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 very careful with fractions. When you've got an h in the bottom, it's canceling with each one of these little terms individually. You can always think of it as the common denominator and double check yourself. Hope you found this helpful and look forward to providing more helpful solutions in the future. If you have any tough questions you'd like to send, just send them to themathinformant@gmail.com. Have a great day. Bye-bye.